Hi, welcome to my presentation for the Part D or Milestone 4 of our class assignment. The topic that I'm going to present today is combating COVID-19 outbreaks. This Milestone 4 or Part D will touch on interpretation and communications of data insights. And this particular assignment itself is an individual effort. And let me introduce myself before I pursue. My name is Hon-Loong, and I'm actually a student for WQD 7005 Data Mining in University of Malaya. As we have actually done multiple milestones in the previous session, this particular session itself will focus more towards how we're going to interpret and communicate the data insights. Let's start with some assignment background. With the recent extraordinary improvement in data collecting technologies that have changed the way for data scientists to make informed and effective decisions, it is very important for us to ensure that we are able to provide effective methods in interpreting and communicating the analytics works from the data acquired. These focus and effective methods includes translating the data into information and possibly knowledge, using statistical and visualization methods for creating artifacts to deliver the insights, and of course, to build compelling data presentations to communicate the findings to the stakeholders. Do take note, for this particular Milestone 4 assignment, I have also uploaded the Python code in our GitHub site as indicated in the hyperlink here. Before I pursue further, let me share with you the process of how my team have actually went through in acquiring the data sets. First, we have actually acquired the data sets through the web crawling method. From the near real-time data that we acquire from the internet, and we have stored it into our cloud storage, or also known as data lake. On top of that, if you recall from my previous session of the assignment that I've recorded, we have also acquired different data types. And for this case, we have also acquired a data type from Twitter, all right, so that we can actually do a more thorough analysis, which I will touch on later on, and hopefully, we will be able to include it by the end of our assignment. And from this case itself, as you can see from the chart on the left side of this presentation, we have acquired the data from Johns Hopkins University based on the near real-time or the latest updated data globally, and which is always a day earlier from when we acquire the data. For example, if I acquire the data today, the data that is going to be acquired will be based on yesterday. And once we have actually acquired data, we have actually stored it into our data lake, which we have leveraged on the Google Cloud platform. And from that on, we can actually use to store multiple different data types that we have acquired, be it structured and unstructured. Now, once we have actually acquired this data, basically the next step that we have went through in acquiring this data set is to develop the visualization and the analytics forecasting tool using Python. All right, and for this case, I've actually followed the KDD process, or known as the knowledge discovery in database, as highlighted on the left hand side of this chart itself. So as you can see, based on the data that we have acquired, I've actually went through the selections of the target data that we're going to use, right? For this particular analytics, and then we're going to pre-process it, basically to do some data cleansing and cleaning, right? And then we will actually go through the transformation of the data set so that it can actually be transformed to do a proper data mining access that we're going to pursue with. Now, based on those data mining that we're going to introduce later on, based on the pattern that we have acquired, then we will interpret or evaluate based on the information that we have, and then we will generate knowledge. And this is the overall process that we will be going through, in this particular exercise itself. Now, to start with, let me go through with you how we went through the pre-processing of the and transformations of the data sets. From the data that we have acquired, as you can see from the left side of this screen, basically what we will need to do is to remove all the outliers and apply the strategies for handling the missing data. Then what we do next is to look at from the data sets that we have acquired, because the data that we have crawled from the internet or the Johns Hopkins University website comprises of three different data sets, which covers the cases for confirmed COVID-19 cases, the death cases for COVID-19, as well as the recovered cases. And there are also numerous number of features or columns that is actually being introduced. And obviously, in order for us to be able to do a better analytics, it's important for us to do and do some data reduction, leveraging on the useful features that we're going to represent in our data analytics moving forward. And based on the data that we have collected, all right, there are actually necessary informations that we can actually leverage to build the right model for us to do the data mining. For example, over here, we can see that out of all those files that we have actually cropped from the internet, in actual fact, there are only about 177 countries that are in the data sets. And out of these 177 countries, as you can see from the transformations that I've actually done on the data set, I've actually combined the data and actually pivot it so that we can actually group it by confirmed case, new cases, death cases, or recovered cases, in one single data frame or data set itself. And over here, I can even look at, based on the date that I've actually acquired data, how many countries have more than one confirmed cases, 10 confirmed cases, 100,000 or 10,000. And this is where, by collecting all this necessary information, it will help us to model our data mining more effectively. This is actually a sample of all the interpretations of the data that we have acquired, and based on the data mining and interpretations that we have done on the data sets that we have done, these are some of the example of the descriptive analytics generated by myself to develop the code using Python. Rather than going through the presentation only, let me actually run through the code itself so that at least you can experience the real descriptive analytics that we are actually able to introduce using Python code. This is actually the code that we have developed. Now, to start with, we need to import all the relevant libraries and packages for this particular assignment. So let us run this file. So just jump to the bottom. So let me run again. To make sure it's actually successfully run, you will notice that the number will change, as you can see. Now, it takes a while. The first time reason behind is because I'm actually importing quite a number of libraries due to the fact that I'm actually going to apply not just the descriptive analytics portion in my code, but there are some predictive analytics that I'm actually including as well. Hence, you can see there are multiple different libraries that I've actually included. Besides the standard libraries, for pandas and also for NumPy, I've also imported the libraries for me to plot the graph using matplotlib and also Seaborn. And in order for me to crawl the data sets, I've also used the package from Beautiful Soup. All right, and obviously, in order for me to do to build up the model to do my prediction, I've actually used a lot of the packages and libraries from Skittit or the sklearn model, and these are some of the stat models that I'm also using as well in my code. So let us run and acquire the data to begin with. So right now it's actually going to the Johns Hopkins website to acquire using the Beautiful Soup package. And to ensure that the data is actually acquired. So let me run the data sets that is actually shown here. This is actually the data sets for confirmed cases. The next is actually the data set for death cases. And last is actually the recover cases. You notice that there are actually three different data sets here. Reason behind is because I'm actually crawling three different data sets, three different files from the internet. And obviously, in order for us to do data analytics on three different files, it could be very difficult. So to start with, I think it's actually important as well for us to follow the KDD process, all right, as I've actually introduced earlier in my presentation, where we need to actually do some of the data cleansing and converting the data type, to the right data set types for us to do our analytics further. So let me actually run this. Next, I'm actually going to convert some of the column names, instead of having underscore different cases, whether it's lowercase and uppercases, I'm actually going to rename everything and actually convert everything into a lowercase. So this is where I'm actually going to start combining different data sets file. For this case, you notice that I'm actually using the melt function from Python. And let us start with our first business intelligence based on the data sets that we've acquired. So what I've done is I've actually combined all the data into one single file itself, or data frame. And as you can see, these are all the acquired data where I've actually added three columns for confirmed cases, death cases, and recover cases, all in one single data frame. And in order for me to actually do a better analytics, it's also important for me to start looking at what are some of the new cases that we are able to acquire based on the data sets that we have downloaded. And over here, right, you can actually see that I've also used the sum, all right, from the confirmed fatalities of records, and I've actually combined, and then this is where I can actually know, for each day, how many confirmed cases are there, how many fatalities are there, and also new cases. This is actually another better view for me to pivot or combine the data sets, the data that I've acquired into categories, based on the variables here, confirmed, new cases, or fatalities that I have. So again, this is actually another method, for us to view the data, so that at least we know, how many rows are there and how many columns that we wanted to view for ease of analytics. Now, let us start with the first visualization. And over here, what I've done is I've actually used the PX or from the Seaborn Matplot libraries. And I've actually used this to actually combine all the data that I've acquired and able to describe how many confirmed cases overall, since the day it started. And for this case, our data was actually started since 22nd of February till today. All right, and over here you can see there are confirmed cases, fatalities cases, and new cases. And notice that in our method of describing the analysis that we have done, what I've actually coded in my chart is that this is actually very interactive, where I can actually move my mouse over and I can actually see how many cases have been increased on a day-to-day basis. With this manner, it actually gives my audience a better view, a better perspective of how the data has been generated, and based on the data, we will know from over time, how many cases are there for confirmed fatalities and new cases that we have uncovered. The same goes for fatalities here and also for new cases. Let us run a different perspective of how we see or what I would describe as illustrating the rate of the growth reported cases. And over here, I actually use the log scale. And this is actually a very interesting chart where we can see that, from the confirmed cases, we are starting to see that it's starting to gradually, well, it's still growing, but it's actually growing steadily and not a very linear manner. All right, and the same goes for the fatalities. But then from the new cases itself, you will notice that this is actually a very good insight where it actually shows that the number of new cases on the day-to-day basis is also starting to flatten down. So let us actually run a different report. And this is actually a chart that shows the mortality rate over time. And this is again a very good sign where we can actually see the number of death cases initially, especially during the end of February to the April, there were a significant increment in terms of number of death cases. But from end of April onwards, we are starting to see that the number of death cases are more controllable and is starting to gradually going down. Again, based on the data that we have acquired, it actually gives us a very good insights to monitor and also to look at the cases that is being reported on a day-to-day basis. Now, besides looking at the chart standpoint, we can also look at it from a table form. And over here, what I've actually done is to analyze on the COVID-19 growth of confirmed and fertility cases, including the recovered. And this is actually a very good way for me to combine, all the number of cases on a day-to-day basis, by country. And here I can actually look at, for each country, how many in totality that it has acquired on the confirmed cases, fatalities, and recovered. So again, this is also a very good way of how we can view it, in a table form, besides looking at chart. Now, obviously, when we actually run through these data sets, it's also very important for us to know how many countries are there being covered. And over here, even though we know that there are in our global worldwide, there are more than 177 countries. But in these data sets, we notice that there are only 177 countries that's being included. Reason behind is because there are some countries that are not being recorded and they have not been updated. Therefore, what I've actually done was I've actually removed all the null values, and there are actually 177 countries in the data sets that we can do further analytics on. This is actually just a method for me to, start creating an array out of these 177 countries. Moving forward, how am I going to analyze for the ASEAN countries? And therefore, I've actually used this method to create an array for me to group all the ASEAN countries. And to start with, what I can also look at from this data set is to look at the number of cases, where I can actually categorize it like, how many countries have more than one confirmed case, COVID-19 cases as of, the data that is being acquired. And as you can notice, the day I'm actually running today is 27th of May, but the data set is actually, like what I've explained earlier, a day before, which is on the 26th. Now, this is actually the latest data set that's being uploaded globally, by any part of the world. And, we will always get a day behind data. Therefore, that's why I've actually renamed this as near real-time data sets instead of real-time. Nevertheless, this is actually the best that we can get for COVID-19 at the moment. And we can actually categorize it like, how many countries are there that are having cases that have just one confirmed cases, or 10 confirmed cases, 100,000 or 10,000. Now, this is actually for global. And the reason why I've actually have ASEAN array just now is also so that I can actually run my analysis next to look at among all the ASEAN countries, how many ASEAN countries have more than one confirmed cases. And for this case, they are or have more than one. And for this case, there are 8. 10, there are actually 8 as well, and 100, there are 8. And then for more than 1,000, there are only 5, and more than 10,000 confirmed cases, there are only 3 countries across ASEAN. And we know these countries comes from Singapore, Indonesia, and Philippines. besides looking at it in this format, we can also use a different way of conveying the message using graph. And for this case, I've also used a different method using this plot to categorize the number of cases by countries globally. And here it also shows a very simple chart in terms of like how many countries are there, and it's also, again, it's a different perspective of how we view the data. Now, besides looking at just the line chart itself, it's also very important for us to look at, how, based on the data that we have acquired, how many countries are there that have confirmed and fatalities COVID cases. And over here, I can even actually use, my analytics to do the descriptive analysis to show my audience among all the global countries or the 170 countries that I have in my data sets, United States or US have the most number reported confirmed cases. And for this case, you can see there are actually about, I would say, more than 1.6 million already as of yesterday in terms of the confirmed cases. And then, of course, in terms of the fatalities or death cases, they are already almost 98K of confirmed cases of fatalities. All right, and the same goes for the rest of the countries. And what I've also done was to sort it based on the top number of cases reported all the way to bottom. And again, this is also another way of, uh, I believe, an effective way of how we can describe the insights of the data that we have acquired. Now, obviously, looking at global, sometimes it's actually very difficult to look at information or data that is more closer to us. So what I've also done was to then group it by the ASEAN countries. Now, instead of looking at the top countries globally in terms of the number of confirmed and fatalities cases, I can also, based on the area that I've created, I can actually group by the ASEAN countries. And over here, you can see that, as you can see, there are 3 countries that have more than 10,000 reported cases. Malaysia is actually on the 4th position, where we have, as of yesterday, about 7.6K cases reported. And there are also about 115 death cases or fatality cases that's being reported today from Malaysia. But of course, one interesting information that you can actually uncover from this data was that even though Singapore has the most number reported cases, and for this case it's about 32,343, right? But you can see that the number of death cases is very low. Now, this is actually a very, very interesting insight that we have actually able to monitor. And for Indonesia, you will notice that they will have, quite a high number of confirmed cases, but at the same time, that their fatality cases are also very high. The same goes for Philippines. Whereas for Malaysia, I think it's actually somewhere between the control situation, where even though we have the confirmed cases that are quite high, but again, our fatality cases are currently under control. However, I think Singapore is able to do it more effectively from this chart itself, as shown in this chart itself. So this is actually another way for me to analyze further, to do, based on the the data that we have acquired. I'm able to look at, which are the top 30 countries that have the confirmed cases. And over here, you can see that there are quite a number of countries here. All right, these are the top 30 countries. And sometimes looking at this chart itself, by just top 30, it's not very informative, right? Because you see quite a number of lines that's being jumbled up. So what I've actually done to make it more effectively is to even able to allow my audience, right, to actually select a particular country which they are actually interested to look at. Now, if let's say I'm actually interested to just look at Singapore itself, I can just click on the country, and over here it will be able to show the country data, of how the number of confirmed cases have grown, gradually on a day-to-day basis up till yesterday. And if let's say I want to compare it with another country, and for this case, if let's say I want to compare it with China, over here you can see that this chart will also be interactive enough to display, all right, to my audience, the comparisons of the confirmed cases, as of yesterday, and this is actually also shows that based on the reported cases, China is starting to stabilize. All right. Therefore, you see it's actually going flat. All right. For quite a period of time. Now, besides comparing to this, maybe it's also good for us to compare to other countries. For example, let's look at where is other ASEAN countries. If I can actually find one, looks like that is not available here, but perhaps over here. All right. If I can actually compare to US, you can let me unselect Switzerland. You see that the number of cases in US growth is actually very, very high in comparing to number of cases in Singapore. Now, the rest of the chart also shows a similar situations where I can also be very interactive to look at the top fatality cases. Now over here you can see these are this is actually the highest number of reported death cases or fatality cases, and that's actually in US, right? And if let's say I unselect United States, it will actually show me a different perspective of countries that have a more equivalent number of cases being reported, and this is where we can compare the country in terms of the reported cases based on the data that we have acquired. So from the way of how we describe the analysis based on how we actually present our descriptive analysis here, you will notice that a lot of the chart that I've actually created here are very interactive and it's not stagnant. So therefore, it actually allow my audience to be able to view the data based on whichever country they are interested to look at. Now, obviously, besides looking at a line chart itself, again, I can actually look at the high mortality rate. And how do I actually get that? It's actually to look at the number of fatalities divided by the number of confirmed cases, right? And these are the top 30 countries that's being reported as of yesterday in terms of the highest mortality rate. And if I want to look at the lowest mortality rate, right? These are the top 30 lowest mortality rate that you can see, that's being reported out. And that's what you can compare from the chart earlier. Singapore really has a very low mortality rate with a percentage of 0.0007%, right? And that is a very, very good way of how the country in Singapore has actually controlled the cases. Now let us start plotting for the rest of the ASEAN countries, because what you saw just now in the earlier line chart that I presented is actually on the global, and sometimes it can be very distracting because there are just too many data and insights. And in order for us to narrow it down, for us to do a more effective descriptive analytics to share with our audience, we can also group it by the ASEAN countries. And over here you can actually see, which are the most highest confirmed country that was actually reported with the COVID-19 cases as of yesterday. And here we can see that Singapore has the highest year to date, followed by Indonesia, then Philippines, Malaysia, Thailand, Cambodia, and so on. So with this way, we can actually look at the data more effectively. And if let's say we are interested to look at from a day on which particular day, we can actually move our mouse over and it will actually show us the data itself. Besides moving the mouse over, if let's say I'm just interested to look at Malaysia, I can also just click on the Malaysia country and I can actually view all the data, in terms of the confirmed cases that's being reported out, and then it's actually being illustrated in this chart. Next, this is actually a chart for us to look at the number of recovered cases for ASEAN countries. And then I'm actually going to share with you the number of fatality cases that was being reported as of yesterday, accumulated number of cases. And again, you can see that Indonesia has the highest number, followed by Philippines, next Malaysia. Now, besides looking at, again, from a line chart perspective, we can even look at it from a bar chart or histogram, where we can actually see it from country, and then we can actually articulate it in terms of their mortality rate. Now, it's all up to us how we want to describe, but over here, what I've actually demonstrated was to present a few ways of how we can make our descriptive analytics more effective and easier for our audience to view. Now, besides looking at a chart standpoint, I can actually even create my descriptive analytics using a worldwide map itself. So let me run this file. And over here, it will actually generate a heat map to look at the number of country cases. Obviously, the darker the color shows that's where the highest number of reported cases. Again, this is actually the number of reported death cases or fatalities. Again, this is actually a heat map, world map that I've actually presented. So again, this is one way or another method of how we can actually present our analysis based on the data that we have acquired. All right, and again, this is actually the number of mortality rate. I can actually zoom in if I want to, based on whichever country that I want. So let's look at the other type of chart that we have actually created here. So this is actually to plot the fertility growth for countries since the 10 death cases that's being reported for that particular country. You can see that these are the listed, and obviously it's a bit overwhelmed when there are too many countries. So what we can actually do is to look at how the countries have doubled since the 7 days, 14 days, and 21 days. As you know, in every 2 weeks, that's where we will see whether the country is actually under control in terms of the number of reported cases, or even are they able to control the number of death cases based on the medications that they have actually provided to the patients that have been detected with the COVID-19 symptoms. So let us actually select a few countries, and over here let me choose Malaysia. As you can see, this is actually a way for us to also present our analysis on a descriptive manner, where on a week-to-week basis, we are able to actually start to gradually control the number of death cases to a rate that is actually controllable. And if let's say we select US, for example, you'll see that the number of death cases keeps increasing, all right, quite in a quite scary mode. So if let's say we're going to choose another country for this case, let me actually choose China. See, because China was actually the first country that has reported the number of cases, right? So where is China? Yes, over here. You'll see that China has also shown that there is actually a significant growth at the initial stage, but then it actually started to grow flat. But all of a sudden, somewhere between the day 85, I think, yeah, there is actually an increment of death cases again. All right, then of course, then it actually start to flatten out. Now, this is actually based on the real data. As we can see, there was actually reported as well in the internet that China outbreak in Wuhan has raises the death toll by 50%. And this is actually some way that was actually being reported in the during the 17th of April, as published here in the internet. All right. As a result of that, that's why we see that it's actually a sudden increment. All right, and then you actually went flat again. So what you're seeing here are based on all the real cases that is being reported, being monitored by WHO. All right, and as a result, when I actually do my analysis here, you will see that it will reflect accordingly in the chart by itself. So let me run actually the next code to see, the number of confirmed cases on a daily basis. Now you see that, on a day-to-day basis, the number of cases, for countries, and over here, these are the top 30 countries, has actually, there are some countries that are actually growing initially, and then they're starting to have a very unstable, up and down growth. And then, of course, for this case, you're seeing that, US is actually on a day-to-day basis on the past few days is starting to reporting to have a lower number of new confirmed cases. Whereas for Brazil, it's very interesting that we see that there are actually more cases starting to grow back again, compared to 25th of May, to 26th of May. All right, and these are just again, some of the countries that we can choose. And if let's say we want to just choose one single country, again, we can actually make it very interactive to look at it, in such a way. This is for Philippines, and let me see if I can actually find any other ASEAN countries. Indonesia. Oops. Let me unselect India. Right, Indonesia is actually the one that is highlighted in blue. All right, and here you can see that the Indonesia number of death cases is still the highest. All right, however, it's actually starting to drop, whereas in Philippines, it's still showing that it's still increasing in terms of number of death cases. So again, this is actually another way of how I've actually described based on the analysis that we have done from the data that we have acquired. Now, besides doing the manual interactive on the chart itself, what I have also created is actually an automated manner for us to look at the confirmed case COVID-19 cases spread over time, since the day is being reported, which is actually on the 22nd of January till as of yesterday. And what I can actually do is to press on the play button, and basically what it will actually show is to start populating the number of confirmed cases into the world map, so that you can actually see how it's actually being impacted to global countries in our world, all right, of the number of reported cases. And that's why COVID-19 has officially been declared as pandemic by WHO. And for me to speed it up, I can actually just drag or just press stop here, and I can actually drag, and you can see the number of growth and the color changes based on the confirmed cases rate that I've actually selected. The same goes for the fatality cases, and also for the new cases reported daily, which I can also show it in my chart here. I'll let it run by itself, and you'll see that it will auto-populate by itself again. And next, for this one, let me just drag, and you'll see that the number of increased cases that it has generated. Right here is still running, so to save time, I will actually just drag it, and you'll see that again, the number of reported worldwide fatalities by country in the world map, how those countries has actually been impacted. Next, I'm actually going to illustrate, more specifically for Asia Pacific. So let me run the chart again. And here, you'll be able to see the number of confirmed cases in selected Pan-Asia countries, and I can actually move my mouse over, and it will show the report as well. Besides looking at just Asia, I can even drill down further, for China, because China, in the data that we've acquired, the beauty of it is that they actually split it by province, and I can even actually go by province if I want to, all right, by just clicking on this, and then you can see this is actually Hubei, all right, that's why which is where Wuhan is located. And if I unselect that Hubei, you'll see that the chart will reflect all by itself. And if I want to just look at Hong Kong, all right, number of cases, it will also again, reflect, based on the number of cases that's being reported, as of yesterday. So these are just some of the descriptive analytics that I've actually present to you. So let me actually start running, some um, modeling method so that I can actually pursue, with my predictions and forecasting, for our particular assignment here. So I'm going to run the data. Again, I'm actually going to name my data frame as COVID-19 datasets, which I've actually trained it based on the combined different data sets that I've acquired into one single data frame. As you can see, you can now see in one data frame itself, you have confirmed fatalities, recovered cases, all combined together. Right, and then I'm actually going to just run this to prepare my data sets. And I'm actually going to do some training, all right, so that I can actually group some of these data sets based on how I would like to do some analysis. And over here, you can actually see that, for me to sort the number of countries and group them, by, confirmed cases. Here, I can actually see immediately, US has the highest number of reported confirmed cases, which is actually, as of yesterday, 1.68 million. Wow. Then followed by Brazil, Russia, and so on. And then I can also look at, next area where I can see, the countries based on their dates that's being reported on the confirmed fatalities and recovered as well. So as this is actually a time series data set that I've actually acquired, what I've actually done was to build a model to do our time evaluation. And for this case, I've also tried to do a further analytics based on the confirmed cases, the fatality cases as well. So let me run my file to share with you. For this case, I can actually look at the confirmed cases, based on the time series data that I have for Malaysia in particular. And if I want to look at the fatality cases for Malaysia, let me run this code. Again, you'll see that this is actually the fatality cases, based on the time series report that we have generated. But of course, if let's say I want to run a few more countries together and compare it, I can also include it as part of the parameter, based on the confirmed variable and also the fatalities variable, and then I include the number of countries that I want to compare, and here you go. It will also generate the chart based on the time series that I've acquired. So I'm actually going to convert this into a real date format for data type, and I'm actually going to do some comparison here. And here I'm actually going to run some of the time compare for different countries against Malaysia. This is actually confirmed cases in 8 days between Malaysia and Singapore. And over here you can see if I want to compare Malaysia with Indonesia, confirmed cases in 6 days. Indonesia seems like they're still growing very, very rapidly. The same goes for Singapore. And then Malaysia compared to Philippines. And of course, Malaysia compared to US, and US is actually growing very, 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 very high. And if I want to compare US versus other countries, as you can see, US is actually highlighted in blue. This is actually comparison between US and China. This is for US and Russia, US and United Kingdom, and US and India. And this chart itself, basically what we have able to describe, based on the time series that we have done on our analysis, it shows that the number of cases in US is growing significantly higher in comparing to the rest of the world. And of course, in order for me to ensure that I'm able to do a further analysis on the data that I have, based on this pool of time series data sets that I have actually acquired, I'm actually going to apply the ARIMA, or known as the auto-regressive integrated moving average model, for me to actually test out, the data so that I can actually do, some prediction whether, the cases that it's actually going to have or it's going to happen in the following week, will it actually increase or not? So before I actually do that, I have to look at the medium average roll, in terms of the medium rolling mean and also the rolling standard. So this is actually for Malaysia, and then I can also see for other countries like Singapore, China. As you can see, China is actually flattening compared to other countries. All right, and then Vietnam, and of course US, and my apologies for all the messages, and also for United Kingdom. Okay, let me, to reduce all the disruption, I'm going to close that file. Okay, now next I'm actually going to look at, other reports to look at the time series decomposition. Now this is actually a very, very good analysis where I can actually look at the residuals, whether there's seasonal, and what's the trend like for the countries that I'm actually going to highlight here. And for this case, this is actually for Malaysia as of the data sets as of yesterday. And you can see that, this itself is actually showing that, initially when it first started, we were actually, quite flat or slow, and then, all of a sudden there's actually a spike, and then it drops. And this time, seasonal is actually not very effective because this is actually on a daily basis, right? Therefore, you can actually see that, it's actually ups and down, ups and down. Therefore, you notice that the data set that we are having here are not 100% stationary, but the trend that is actually showing that is, for Malaysia, that is that, for the confirmed cases is still growing, right? So this is the observation, and the same goes for the other countries. For this case, Singapore, I'm actually running it. Next, I'm actually going to run for China, Vietnam, US, UK as well. So let it generate all the reports, and you can see that, these are the reports that's being generated. And of course, for China, as we all know, it's actually starting to flatten out, since, much earlier in March timeframe. All right, and then of course, for Vietnam, it's also starting to gradually, flattening down or slowing down. All right, but of course, for US, it's still growing very significantly, and the same goes for UK. So based on this time series decomposition, it's actually important for us to also look at the data, whether these are all stationary or not. So what I'm actually going to do is to actually run through the Dickey-Fuller test, right? And here I'm actually going to run the report for Malaysia, right? As you can see, these are the results that's being generated from the test statistics. You notice that the test statistics here reported is actually lower compared to the critical value. Therefore, it's actually showing that the data sets for Malaysia is not that stationary because it's still moving on a day-to-day basis. The same goes for Singapore, all right? And then for China, you'll notice that test statistics here is larger compared to the critical value. Reason behind is because the data sets that we have here is more stationary. Therefore, it's actually going to be more effective when we actually run the predictions model that we're going to have based on the RMR model data. All right. Same goes for Vietnam. It's actually close to the critical value. All right, and also for US, again, the test statistics here is still smaller, compared to the critical value, and then also for UK. Okay, so here you'll be able to see all the results that's being generated, based on the model that we are actually trying to diagnose on the data sets that we have. All right, and what I'm actually going to do next is to look at some of the correlation. I'm actually going to run some of this. This is just going to populate some of the correlations between the autocorrelation function and also the partial autocorrelation functions that I'm actually running for the country, right? In terms of the hypothesis of the non-stationarity of the data, the confidence. All right. So again, these are some of the charts that I've actually generated for Singapore, and this is actually for China. And next, what I'm actually going to do is to run my prediction, model of how will all this data that I've actually acquired to predict, what will happen in the following week. So I'm actually going to run this data sets. I'm actually going to train, my features, and I'm also going to start running, some of these training feature sets for the data that I have. And over here, you'll notice that what I've also done was to split my test data and also my train data in 80-20%. So for me to run my training data, I'm actually going to use 80%, whereas the testing, I'm actually going to use 20% based on the overall data sets that we have acquired here. So let me going to run this file, this code, this set of code where it will actually do my mean absolute percentage error for various different country. Here is actually for Malaysia, and then I have for Singapore. Next, I'm actually going to have it for China. Then next one is for Vietnam, and then of course this is actually for US, and lastly for UK. So let's see, how the report is turning out. So it's still running. Let's give a couple of seconds to see how the model, based on this ARIMA model that we have used to decompose the time series data that we have. Looks like Malaysia has completed its analysis. And this is actually, sorry again for disruption. All right, you can actually see this is actually dated as of today, 27, when I run this report. All right, and the mean absolute percentage error is actually about 9.6%. And over here, you will see, the prediction of the number of confirmed cases that's going to happen in Malaysia. Now, as you can see, this is actually as of end May timeframe, and in the following week, when it comes in the early June timeframe, we are still seeing, based on the model that I have actually created here, is actually predicting that the number of confirmed cases that's being predicted or forecast will still continue to grow within this 95% confidence interval section. All right, and this is actually the true value versus the prediction value of COVID confirmed cases in Malaysia for the coming week. The same goes for Singapore. All right, again, we are still also seeing that, based on the model that I've actually developed here, is actually forecasting or predicting that it will still continue to grow in the following week in terms of the number of reported cases, for Singapore. And as for China, still running. Let it run a few more seconds. So based on this analytics that I've actually done here, you can actually see that, besides doing the descriptive analytics, what I've also included in this particular assignment is also to do some predictive. And of course, myself and my group member Azwa Kamarudin is currently exploring to look at some model where we are actually going to include some sentiment analysis to help us to do some prescriptive analysis, and hopefully, we will be able to incorporate that into our assignment towards the end of our submission. So over here is still running the mean absolute percentage or the ARIMA model for China. Reason behind, I think, is because the number of data is very large. Therefore, it's actually taking some time, to run. And it has to complete the China before I can actually pursue for the other countries. So while waiting for it to run, let me go back to my presentation, right, to actually give you a brief summary of what I've actually covered. All right, so what you have also seen just now, besides the descriptive analytics, based on the interactive charts that I've actually generated, for my audience to view. We have also did some diagnostics in terms of the data sets that we have, leveraging on the time series decomposition evaluation model for the selected countries over here. And these are some of the reports that we have generated. And these are actually some of the prediction that we have actually churned out based on the model, the ARIMA model that I've actually included, all right, in my analytics. And here are some of the results. As you can see, this is actually for Malaysia, Singapore. This was actually run as of 25th of May. All right, as you can see, China is actually going, quite flat, in terms of the number of reported cases. Same goes for Vietnam. But again, for US, we are predicting or forecasting that it's going to continue to grow in the following week, and the same goes for UK. All right, so these are some of the reports that I've actually able to generate here, and let me actually summarize based on what I've actually presented. So data analysis and interpretation have now taken center stage, as what I've actually mentioned earlier, with the advent of the digital age, because everybody is able to acquire and generate a lot of data, and right now is very, very important for us to put it as a center stage to do a better interpretation and communicating the insights to our audience. It's capable of the capability of displaying key performance indicators for both quantitative and qualitative data analysis are ideal for making fast-paced and data-driven market decisions. Now, this is actually very, very important, for us to include both quantitative and qualitative data, for us to analyze. And of course, we will also like to review, based on the data interpretations that we refers to the implementation of the process through which the data is reviewed for the purpose of arriving at an informed conclusion. Now, by just showing you the chart, it doesn't mean anything, but with the insights that we are able to extract out from the data that we have acquired, it will actually give us a better informed conclusion in terms of what should be the next decisions that we should make, so that we will be able to act upon next, based on this overall analysis that we have done. And the interpretation of the data assigns a meaning to the information analyzed, and it determines its significance and implication. Now, of course, over here, it's very, very important for us to assign a meaning to each of the informations that we have analyzed. And for this case, in the earlier demo, I've also shared with all of you, how we can actually leverage on the confirmed cases, the death cases, and also the recover cases to churn out different insights and information, for us to generate a better knowledge for us to make a decision. And based on those knowledge that we've acquired and the patterns that we have monitored, we can then do a better prediction of how this whole situation or the pandemic going to happen. And the facts and figures are meaningless if you can't gain valuable insights that leads to more informed action. So over here, you have also seen that some of the analytics solutions that we have covered include descriptive. I've also included the diagnostics to look at my time series decomposition. And then, of course, based on the time series decomposition diagnostics model that I've actually tested out, then we came up with our predictive model based on the ARIMA, which is actually the mean average, all right, to predict what is most likely going to happen in the future. And for this case, in my demo earlier, I've actually presented, how we're going to predict for the following week situations for confirmed and also for the confirmed cases in selected countries. And of course, we are currently still working on the prescriptive analysis, all right, and hopefully, this is the part that we can actually include, for us towards the end of our submission of this assignment. Now, obviously, when you look at each of these analytics, the descriptive and diagnostic is what we will term as leveraging a lot on the past information, or we will term it as business intelligence, for us to look at, what are some of the descriptive analytics that we can actually generate out of it, right? And when we move further to the right, you will notice that the complexity starts to get more and more complex. And of course, even for us to run the report, and to run the analysis, it also takes a longer time. All right, therefore, there are more complexity, that is being incorporated in our code to build the model. And of course, with the complexity increase, the value will increase as well, right? And therefore, it actually turned out a predictive model, for us to look at, how we're going to predict some of the countries are going to happen in terms of the number of confirmed cases. All right, and of course the prescriptive. And for this, both predictive and prescriptive is what we would term as future forecasting that we can actually incorporate into our data analytics. So with that, I would like to thank you for your time to go through our presentation and demo. And shall there be any questions, we look forward, and I look forward for you to ask during the class. With that, thank you very much.